so we're going to go ahead and redo these last four for you guys so you can see how they're done. Got angle DAM is 42 degrees, DAM, so I'm going to write that in there, 42 degrees. Angle MCB is 30 degrees, MCB is 30. And angle MDC is 75 degrees. Okay. Now, we also know that we've got four 90-degree angles on the inside because diagonals are perpendicular in a kite. Find the measure of angle ABM. That's this angle. Okay. Now, what we're going to do is we're really going to focus on, let's change colors here. We're going to focus on this top left triangle. Okay, and the reason being, because we know we can find these angles, except for this last one here, we know what these other angles are. We know we got a 90-degree angle in here. Okay, we know that we've got this 42-degree angle is also 42 up here. And the reason we know that is because this diagonal AC, that's our line of reflection in this kite. So directly across from it, this is also 42 degrees. So we have two of the angles, 42 and 90. If we add them together, we got 132. If we subtract those from 180, we got 48 degrees, which is what this angle in there is going to be. Okay, 48, and that's correct. Okay, now this one, number 6, we know that angle ABM is 8x. ABM is 8x. So I'm going to write that up here, 8x. Angle MDC is 75. MDC, 75 degrees. Angle ADM is x plus 70. ADM, x plus 70. Okay? Now, because this is my line of symmetry, okay, I know that this angle 75 is also up here is 75. I keep forgetting to hit the pen. I know that this is also 75 because we're trying to solve for angle ABC, which is this big angle up top. Okay. Well, we know this part over here is 75. This part, it says is 8x, but we don't know what x is. But I know that this 8x and this x plus 70 are congruent because they're both the same part when they're reflected over the line of symmetry. So I can set 8x equal to x plus 70. Subtracting x from both sides, I get 7x equals 70. Dividing by 7, we get x equals 10. And when I plug that in here, I'll get this angle to be 80 degrees. Well, add them together to get the full angle ABC. 80 plus 75 is 155. Okay. Number 7. All right, this one, we are given angle DMC is 5x. DMC is 5x. Now that's, right away I know that that's a 90-degree angle, so I know 5x equals 90. And when I divide both sides by 5, we get x equals 18. Okay, so we know what x is, which is big because we're going to need it here in a second. Angle MCB is x plus 4. That is this top angle. I could go ahead right away and figure out what that equals. If I do 18 plus 4, I get 22. We want to find the measure of angle MDC. MDC, which is this angle down here. Okay, I want to focus on this bottom triangle. Why? Because I know two of these angles. And the third angle is the one we're looking for. Now, how do I know two? Well, I know this is 90. So I'm going to go ahead and just write down 90 here. That's 90. This small angle over here, it's congruent to this angle up here. So if that one's 22, so is that one. Well, I now add these two together. 90 plus 22 is 112. I'm going to subtract that from 180, which gives me a 68-degree angle, which that is what that angle down there is going to equal. Okay, and that is correct. All right, last one. Angle BAD is 52. Well, that's this whole angle over here. So this is 52. Angle ABC is 130. That's this top angle. And angle DCM is what we're looking for, this small angle, okay? Now, we can do this a couple different ways, but I think the easiest way to do this is let's figure out what this whole BCD angle equals and then divide it in half. Because I know that the diagonal, that's the line of symmetry, it cuts the angle in half because these two small angles are congruent. Well, this big angle over here is equal to this big angle. So I have 3 of my 4 angles now. So add these together. 130 plus 130 is 260. 260 plus 52 is 312. So these 3 angles added together are 312. To figure out what this angle is on the right, I'm going to subtract this from 360. And I get 48. So the big angle is 48. I only need half that. So I do 48 divided by 2, which is 24. And that is the correct answer for that one. Okay? Now, I meant to get through all of this today and then talk a little bit about what you guys are going to have to do in your notes video, which is homework. And I'm just going to pull that up real quick so we can see what that looks like. And bear with me as I had to close everything down when the internet went out. So let's see, open. All right, it's right here. It's classifying quadrilaterals. Okay, and this is actually 4.1. And I've got a video with these notes already up for you guys to watch. But just to talk about them real quick, what you're going to do is you're going to be given some facts about a quadrilateral, and you have to give me the best name for that fact. Now, in the notes, I go through each and every one of these. What I recommend that you guys do is that when you get to like the next slide, pause the video, try it on your own, and then check with the work that I show you, okay? But there's 8 examples. The first 2 slides are just kind of talking to you about it a little bit. Then the last 8 slides talk about the different quadrilaterals and give you the facts that are involved with them, okay? Good luck on that. Definitely, I would love you guys to get through those notes and try those problems within the notes before we meet in class tomorrow. When we meet tomorrow in class, we are going to be doing a Kahoot together. And after we finish that Kahoot, you guys are going to be given the review, and you're going to be working on that review for the remainder of class tomorrow. You'll have Wednesday to work on it, and then we'll actually go over the review on Thursday. But the more you do on the review, the better I'm going to be able to pinpoint what we need to work on more when we meet on Thursday, and your test will be Friday during class. Okay? Good luck. Email me if you have any questions. Bye.